Hi, everybody. My name's Jamie, and I'm a solution engineer here at HashiCorp. And like Pete just said, today we're going to be talking about why it's so important to be able to bring and manage your own key with a platform such as HashiCorp Vault. So to dive into this topic, I'm going to start by telling a story. My story starts like this. On the screen here, I've got Sally. And Sally is the CISO at a large multinational bank. That means her job, in a sentence, is to keep her customers' data safe. As the bank she works for is slowly becoming a technology company, she's tasked with making sure no matter what technology her company adopts, she's got to keep her customers' data secure and in compliance with whatever industry regulations she has to abide by. Currently, almost all of her customers' data exists in on-premise data centers. Historically, this has given us some really key advantages when it comes to data protection. Because all her data lives in hardware in buildings that she owns and manages, she can be really authoritative in how that data is handled. Ultimately, she assumes total responsibility, not just for her customers' data, but the processes around how it's handled. Now, Sally, to keep her customers' data even more secure, is going to use encryption everywhere appropriate. She's going to use some sort of encryption keys across her infrastructure. And in the unlikely event that there is some sort of data leak, it's going to dramatically reduce the chance that the data that is leaked is usable by anybody anywhere. But the technology arm of her business keep pushing her to adopt more public cloud. And this introduces a really unique challenge for her. She's got to accept that she doesn't have total control over how her customers' data is handled anymore. She has to now conform to what public cloud providers call a shared responsibility model. The shared responsibility model looks a little something like this. In a software business, all we really care about is the top layer of this diagram. That's our business logic. And this is how we move into new markets. It's how we differentiate ourselves from our competition. And most importantly, it's how we generate our revenue. Everything below there is just an enabler. And it's the capabilities and efficiencies within these enablers that determine how agile we are in the market. And if there's one thing that this industry has agreed upon over the last 10 years, it's that we don't all want to become experts in each areas of this diagram just to build good software. We don't want to have to make our organizations the best in the world at, let's say, managing server hardware just to become a leader in our market. If we're able to consume some of these underlying resources as commodities, then that lets us divert far more of our resources into building great applications. And then we can let someone who's already become an expert in, say, managing server hardware take care of that for us. And this was really the origin story of the public cloud. Amazon launched a platform where you'd have access to on-demand server hardware. Importantly, it is an extension of your own team. You no longer had to manage your own physical premises if you didn't want to. Naturally, as these cloud providers' offerings matured, they began offering more and more services. Now, you don't need to know how to build a globally always available network just to deliver a great banking experience. You can leverage companies who've already proven to be good at that, and then you can consume it from them as a service. As a bank, you don't want to have to foot the bill for a team of operating system experts just to run your application. Your resources are far better utilized by focusing on building great user experience for your customers. And then we get to where we are today, where almost every part of our IT infrastructure is available to us as a service. This allows us to divert far more of our resources than previously possible to the part of our business that really makes a difference to our customers. Now, there's one person that this doesn't help, and that's Sally. Sally's now faced with the problem of how to keep her customers' data secure, even though she no longer has total control over where it's stored. So she's still got her same methods of encrypting data, but now she needs to be very considered about where she leaves her encryption keys. A lot of the cloud native resources that her company wants to adopt require some sort of encryption key material to be accessible up there in the public cloud. But the regulations around her industry mean she has to be far more careful about the processes she wraps around that. That brings about the question, how do we get organizations like Sally's in a position where they're able to exert the same level of control around her customers' data, but in an industry that requires a highly regulated environment. So the solution to this is we have to come up with some sort of mechanism where Sally can generate the keys in her own environment and then securely distribute copies of the keys out to the public cloud. Fortunately, the public cloud providers have already came up with a solution for this. This is called the bring your own key specification. And depending on which cloud provider you go with, they might call it something slightly different. But in general terms, there's 4 things that we're going to achieve by using a bring your own key specification. The first one is your industry might require you to deliver encryption keys with a particular level of entropy or randomness. This randomness might have to come from a hardware device that already exists on your premises. The second one is you might have to contend with the idea that one day you might have to completely remove yourself from that cloud provider. If you do that, you need to be able to take all of your encryption keys with you. The next one is you might have to build in your own durability and disaster recovery processes that are, I suppose, supplement to the cloud provider's processes. To do that, you're going to need to keep a copy of that key outside of the cloud provider's infrastructure. And then finally, you might have some technical use cases that require part of your encryption key to be available both in the public cloud and in your on-premise data center. Now, all of these 4 things are only achieved when you conform to a bring your own key specification. So where does Vault fit into this scenario? Well, Vault's going to give us a centralized place where we can go to in our own organization and operate on key material. We can ask Vault to generate keys. We can ask Vault to lifecycle, rotate, and revoke them. And importantly, it's all within a centralized platform. So we've got a single place to go for auditing and authorization. Furthermore, because I'm responsible for generating the keys myself, then I can use what methods are already approved by my industry as far as generating them keys, like an integration to a HSM. Now, that brings us to the demo for today. Today, I'm going to show you a workflow across both HashiCorp Vault and Azure Key Vault, where I'm going to create a key on-premise. I'm going to distribute that key to the public cloud. I'm going to encrypt some data on-premise, and I'm going to decrypt it in the public cloud. And then if we've got a bit of time, I'll do some lifecycle operations afterwards. So on my screen on the top, you can see we have Azure Key Vault, and I've already got it configured to talk to HashiCorp Vault. On the bottom, we've got my console. So the first command that I want to run is to just generate some key material. Here I'm going to use Vault's API to say, create me a key called demo key. We're going to be able to inspect this key to learn some more things about it. We can see the versions that are available, the type of key it is, and some other metadata. Now, the key that I've generated is an asymmetric key pair. That means I can perform encrypt operations by just using the public key. So to perform my encrypt operation, I'm going to take a copy of the public key from Vault's API, and I'm going to save it to disk on my console. Remember, this is a public key, so it's perfectly safe. The next thing I need is some plain text that I'm going to encrypt. Here, I'm just going to save a string, hashi for life, into messages.txt. And then I'm going to use an OpenSSL library that takes in my plain text, takes in my public key, and returns some base64 encoded ciphertext. So if we inspect this ciphertext, we can see what it looks like. And now we're going to distribute our key to Azure Key Vault. Once we do this, we get a couple of options. First of all, we can be specific about what operations Azure Key Vault is going to be able to do with our key. In here, we say it's for decrypt operations only. Secondly, we say that we want our key to be protected by Microsoft's own hardware security modules. So if we refresh Azure Key Vault, we'll see that our key now exists there. There we go. So for us to be able to do our decrypt operation, the first thing we're going to need to do is find the name of that key. And because it's randomly generated, I'm going to use this command that will save the randomly generated name to an environment variable. I'm then going to use the Azure CLI, and I'm going to pass in the name of my key vault, the name of my key, and my encoded ciphertext that we just saw. And it's going to output a JSON blob, which if we inspect, we're going to be able to see there's my plain text. So we encrypted on-premise with our open SSL library, and then we decrypted through our Azure CLI. The next workflow I'm going to show is what happens when we delete a key entirely from Vault. Sorry, entirely from the cloud provider. So we can run our delete command against the demo key. And we'll see that because we have Azure Key Vault configured as our backend, any operation that we make here in Vault flows through into Azure's Key Vault. So if I was to retry that same decrypt command, we're going to see that this is going to fail. It's going to say that we haven't got access to that key anymore. And that's something unique to bring your own key specifications, the ability to completely remove your key from the cloud provider. So to continue with the demo, we're going to redistribute our key back to the cloud provider. And once we do this, if we refresh it, we'll see that it shows up there again. Because I redistributed, it's going to have a new randomly generated name. So I'm just going to save that to an environment variable again. And then we're going to do the same decrypt operation that we saw previously. So this workflow shows us how we completely removed key material from Azure Key Vault, and we made sure that it didn't work. And we then redistributed the key back up to Azure Key Vault. In this example, I'm redistributing it to the same key vault, but I'm sure you could imagine some scenarios where you might want to distribute it to a different region or maybe a different cloud provider altogether. The last workflow I'm going to show is the rotation of a key. So if I were to ask Vault to rotate demo key, again, because I've got my Azure Key Vault configured on the back end, we can see that any action would be reflected up in Azure Key Vault. So I now have two versions of my key available. If we to inspect this, we'll see both public keys are available to be used, but that's probably not the behavior we want right now. We're likely going to want to disable that first version. So again, just through Vault's API, we're able to disable the first version of the key. Now we can see if we inspect that same demo key, we only have version 2 available. This shows how we can use a standard API that's independent to our cloud providers' key management solutions to do complete lifecycle operations against a key. So that's the end of the demo. Let me just pull back to my slides and we'll recap some of the things that we saw. So the first thing that we saw is the generation of that key took place inside HashiCorp Vault. And that means I can use entropy augmentation that I already have in my own data center, for example, a HSM, to make sure the key that I'm generating conforms to an industry specification of randomness. The second thing that we saw was how we can completely remove key material from our cloud provider. Maybe you're not considering completely changing cloud provider altogether, but you might want to remove a particular service from one cloud provider to another. The next thing is I might have to build my own durability and availability requirements, which I suppose supersede what the cloud provider is able to provide to me. And the only way that I can do that is by keeping a copy of that key in my own infrastructure. And then finally, we showed that the encrypt operation happened on-premise in Vault, and then the decrypt happened over the Azure CLI from Azure's Key Vault. This means we can come up with use cases where we can bridge both public and private data centers. So if you're interested in any of the commands that I just ran, all of them are available in my public GitHub. And I think Pete is pasting that link in chat right now. So that's everything from me. Over to you, Pete.